This is question 16 of section 1 of Natural Sciences Admissions Assessment, past paper 2017. So in this question we have a diagram here which is a circle with a square of length x and it's resting so that it's along the diameter here and it touches 2 points on the circle here. And we want to find the area of the shaded region, shaded in red. So the first thing we need to do is try and work out how we're going to find the area of the circle. Because if we can find the area of the circle or the area of the semicircle, then we know the area of the square is just going to be x squared. So we can do the area of the semicircle minus the area of the square to get the shaded region. So we need to find the area of the semicircle. And how are we going to do that? Well, we need to find the radius, clearly, because the area of a semicircle is pi r squared, so we need the radius. So to do this, we're going to consider the square we have here. So it looks something like this. This is the centre of our circle, and this vertex here is this one up here, which slowly touches the edge of the circle. So this distance here from the origin to the edge of the circle is going to be the radius. So we can consider this triangle here, which is x up here, which is our x along this length, and along the bottom we have a half x because we know this total length is x, and that it's so half of this is going to be half x. So now we have two known sides in x, and we want to find r. So we can use Pythagoras' theorem. So you should recall what this is. So see if you can apply Pythagoras' theorem to this case to find r in terms of x. Okay, so applying Pythagoras' theorem, we have r squared, our hypotenuse, is equal to the x squared and x over 2 all squared. And so we get that r squared is 5 over 4 x squared. Okay, so the next thing we can do, as we said, is to find the area of the shaded region, we need the area of the semicircle minus the area of the square. Now, recall that the area of a semicircle is half the area of a circle, and we know that the area of a circle is pi r squared, and we have our r squared. So, plugging that all in, we do half, because it's a semicircle, not a circle, pi r squared, which is 5x squared over 4. Subtract x squared, because x squared is the area of our square. And we can simplify this down, so we can remove an x squared, because that's common to both terms, to get 5 pi over 8, because we have 4 and a 2 on the bottom here, minus 1, so we have minus x squared. And this simplifies down again, because we have x squared, 5 pi minus 8, all over 8. And so we get that the answer is F.